Hello everyone, we are here for our next session. But before proceeding with today's topic, I would like to just reiterate our last session, which was about searching techniques, because today's topic goes hand in hand with our last topic. The term sorting comes into picture with the term searching. I hope everyone has submitted the class evaluation quiz, as the evaluation will be done on 4th May. I request everyone who still have not submitted their class assessment, submit it as soon as possible, and also note, submit it only once. So now let's do the recap of our last session talk. Searching, as the word suggests, is an operation to find the location of an element in the list. There are two standard types of search. Linear search is also called as sequential search just because search is made over all the elements one by one. This method can be performed on a sorted or an unsorted list. Second, binary search requires the list to be in sorted order. In this method, the list is divided into two parts. 0th element to the middle element, that is the first half, and the middle element to the last element, that is the second half. The search proceeds depending upon whether the target element is greater or smaller than the middle element. This happens because list is sorted. If the element is smaller than middle element, then searching done in first half and the second half is totally ignored. If the element is bigger than the middle element, then searching is done in the second half and the first half is ignored. The important difference between both the search is, in linear search, the input data or the array need not be sorted. It can be sorted or unsorted array. Whereas in binary search, the input data needs to be sorted. The second difference is linear search does the sequential access, that is, it goes one by one, whereas binary search accesses data randomly. So with this, we have come to the end of our recap. Now, I hope each and every one has understood the concept of linear search and binary search. Let's move to our today's session, sorting. As I've said at the start, sorting comes into picture with searching has to be done, when the searching has to be done, which is very evident in the case of binary search, where the list must be sorted for the search to be successful. Sorting arranges data in a sequence which makes searching easier. There are some real life scenarios of sorting. For example, telephone directory. You must have all seen a telephone directory. It stores the numbers of people sorted by their names so that the names can be searched easily. Similarly, you must have all seen dictionaries. What does a dictionary do? A dictionary stores words in an alphabetical order. So, the searching of words becomes easy. Through these real life scenarios, we must have understood that sorting helps the searching easier. So, there are many types of sorting techniques like bubble sort, selection sort, insertion sort, quick sort, merge sort, and heap sort. So, as of now, the sorting techniques that we will be looking into are the bubble sort and the selection sort. So, let's start with bubble sort. Bubble sort is a simple sorting technique. It's a comparison based technique. Each pair of adjacent elements is compared and the elements are swapped if they are not in order. Let's take an example. Here you can see a list of 5 numbers: 5, 1, 4, 2, 8. Using bubble sort, we'll see how we can sort the array given to us. In the first iteration, this technique compares first 2 numbers and changes the order if needed. So here 5 and 1. 5 is greater than 1. So it's swapped because as we have to sort it in ascending order, all the smaller numbers will be on the left and the bigger numbers will be on the right. Swap is done. Then the 5 is again compared to 4. 5 is greater than 4. Again there is a swap. 4 comes here and 5 goes back to the second position. Then the 5 is compared to 2. 2 is again lesser than 5. So it gets swapped. And at the last, with the last element again 5 is compared, where the 5 is less than 8 and there is no swap done. This was the first iteration, wherein the 1 has come to the first as first element. In the second iteration, again the same process starts. Again we compare 1 to 4, no swap. 4 to 2, yes, 2 is lesser than 4, so there is a swap done. 4 and 5, no sorting required, so no swap. Next, 5 and 8, no swap required. This was the second iteration. The third iteration, again the same process. 1 to 2, no swap. 2 to 4, it's sorted, no swap. 4 and 5, no swap. 5 and 8, no swap. So here we have to do the process until we get a sorted list. So here we got our sorted list and the process ends here. To understand it in a better way, let us see an animated video. So here the first element, that is 3 and 2, 3 was greater than 2, so the swap was done. Here the first iteration is completed. Can you see, is the array in a sorted order? No. So a second iteration is started again. Now after the second iteration, still the sorting is still not done for the list of array. So again the third iteration is going to be done. Here 3 and 5 they are sorted, so there is no swapping being done. But in case of 5 and 1, 1 is smaller than 5, so the swapping will be done there. Third iteration done. Now fourth iteration. Fifth iteration. Sixth iteration, and our array is sorted. So this is the way how we do our bubble sorting. This is bubble sorting. So as I mentioned, the second type of sorting that we will be learning about is selection sort is another simple sorting algorithm. And to understand selection sort in a better way, let us see a video to understand the concept of selection sort. In the selection sort, the logic is array is considered into two parts, unsorted and sorted. Initially, the whole array is unsorted, but while we sort it, we start dividing the array in two parts. Like here. Selection is done on the basis of select the lowest element in the remaining array. Swapping is done and bringing the swapped element to the starting position. Here you can see an unsorted array, that is 64, 25, 12, 22 and 11. This is the unsorted array. There is a bar created, and on the left side there is always a sorted array, and on the right side the unsorted array is kept. So selection is done, the minimum of the whole array. Here the minimum element is getting selected. So we are selecting the minimum element from the whole array. So as we can see, we got the minimum element as 11. So we swipe it with the first position, that is 64. The bar gets shifted because the first element has been sorted. That is, the minimum element gets sorted to the left side, and the unsorted remaining array is the same, and again the selection is done for the minimum element. 12 becomes the minimum. Here 22 is the minimum. can see 25 is the minimum among 25 and 64. So the array remains the same. This is how the sorting is done. As of now, in this technique, the list is divided into two parts. The sorted part at the left end and the unsorted part at the right end, as we saw in the video. Let's see an example. Here there is an array of 4 elements: 64, 25, 12, 22 and 11, as we have seen in the animation. So how are we doing it? Find the minimum element in the array 0 to 4 and place it at the beginning. So the minimum element among this is 11. So this comes to the beginning. Then again, from the unsorted, this part, we again find the minimum element, that is 12. 12 goes to the first part. Then find the minimum element from 2 to 0, 1, 2, 3, 4. This is the index of the array. So 0th element to the second index to the 4th index. So which is the minimum? 22. So that's again shifted here to the left and the rest is on the right. Again, among 25 and 64, it is in a sorted array. So at last the list gets sorted in this way as the selection sort. Let's see how the selection sort works. As we have seen in the video, I am just trying to explain you even in a much easier way. Set the first element as minimum. Minimum, we have set it as the first element. Compare the minimum with the second element. So 20 and 12. If the second element is smaller, yes, that is the case here, the second element is smaller, then the minimum, assign the second element as minimum. So now, as the highlighting gets changed, 12 is the minimum. Compare minimum. Right now, 12 is minimum. So compare the minimum with the third element, that is 10. Again, the third element is smaller than the minimum. So again, the minimum gets assigned to 10. So now 10 is the minimum. Compare the 10 with the remaining element, that is 15. So with 15 when we compare, still 10 is minimum. So let's compare it with the second, 2. Here 2 is minimum. So the minimum value is now set to 2. After each iteration, that is each round, minimum is placed in the front of the unsorted list. So 2 goes in front of the unsorted list. So first swapping is done by switching the 2 to the first position, and the first position, which was 20, went to the last position. That was where the 2 was initially present. So in this image you can see the first iteration, wherein we have done the iteration as I have told you. The last step was the swapping was done with 20 and 2. That this was our first iteration. Second iteration. In the second iteration, again the sorted array will be kept as it is, that is 2. We'll start from the unsorted, that is 12, 10, 15, 20. So 12 is compared with the 10, which is minimum 10. So 10 becomes highlighted as the minimum element. 10 gets compared with 15. 10 is still the minimum element. 10 again gets compared with 20. Again, still 10 is the minimum element. So the swapping is done. 10 go in front and 12 goes to the 10th position. This is how the second iteration is done. Now for the third iteration. Third iteration, here from the unsorted array, still 12, 15, 20 is an unsorted array. So we compare 12 and 15, minimum is 12. 12 and 20, still minimum is 12. So already it's in its own place. There is no swapping done there. For the fourth iteration, as we can see, 15 and 20, they are already in place. Hence, no swapping is done. So, to conclude, sorting is a process that arranges data in a sequence which makes searching easy. So, there are many sorting techniques, but the technique which we have learned today are bubble sorting and selection sorting. Bubble sorting, it is a compare and swap technique. We compare the adjacent elements and we swap if they are not in sorted order. Whereas in selection sort, the list gets divided into two parts, the sorted part and the unsorted part. Sorted part is in the left end and the unsorted at the right end. And after each round or iteration, the minimum element is placed in front of the unsorted list and the swapping is done with the minimum element. This is the end of our session. I have even shared with you all a Word file with the exercise solved. You can see it on your desktop. That is, there's a filling the blanks and the question answers. So filling the blanks, as you can all see, I'll just read it for you. Dash is an operation or a technique that helps find the place for a given element or value in the list. The answer is searching. The word binary means made up of two things. Third, bubble sorting technique is comparison based technique. The fourth, selection sort divides the list into two parts to make it in order. Children, list is divided into two parts even in binary searching. But please keep it in mind, that is binary searching, where we divide the array into two for searching an element. And in selection sort, we divide the array into two parts to make it in order. Okay. So the second question, that is the question answers, wherein the first question is, what is the difference between linear and binary search? Linear search, input data may or may not be sorted, and in binary search, it has to be sorted. Linear search is time consuming. Binary search, it is not time consuming. Third, linear search does the sequential access, that is one by one access, and binary search access the data randomly. The second question is, what is the technique used to do binary search? Binary search is a search algorithm which uses divide and conquer. You have heard divide and rule concept in the history. Same way, divide and conquer technique to perform search on a sorted data. The third question is, what are the advantages and disadvantages of linear and binary search? So you can see the exercise has been solved. So I would request everyone to write it and keep it. I once again request everyone to please complete your class assessment, which was given on 27th of April as a quiz. These are the assessment for the month of April, and it will be evaluated and you will be given marks on it. So please children, everyone complete it, submit it before 4th of May. After that, the link will not be accessible to anyone. So, concluding my final session for the month, hope it was helpful and knowledgeable. Stay home, stay safe, take care, bye.